Hello students, welcome to part 2 of solving paper 1. Paper 1 we had selected was the sample paper from our own high school, Dubai. We had already solved the section A in another video. If you have not watched that yet, please do go through the same first and then you can come to this video. Or it's okay if you directly want to get started with the 2-mark and 3-mark questions, which is what we are solving in this video. You can get started with this also and then go back to the previous video for solving the 1-mark questions. All right, let's get started. Section B. So section B consists of 2-mark questions, and ideally for any 2-mark question, you must be spending a maximum of 4 minutes per question. So we should try not to cross 4 minutes for any of these questions in order to manage your time properly for the entire paper. Let's look at the 15th question of this paper. Two different coins are tossed together. Find the probability of getting exactly 2 heads, at most 2 tails. When we toss 2 coins, how many outcomes are totally possible? Let's look at this one by one. When we toss the first coin, so coin 1, you can have either head or tail. There are 2 outcomes which are possible, either getting a head or a tail. Now, after you have tossed the first coin, on coin 2, you can get further 2 outcomes, head or tail again. This head or tail on coin 2 could have happened after a head on coin 1. So, head or tail on coin 2. You could have also had a head or tail after obtaining a tail on coin 1. How many outcomes are there totally? You have 1, 2, 3, 4 total different outcomes which are possible. Either head on both tails, or head on the first, tail on second, tail on first, head on second, or tail on first, tail on second. Now, what are the total possible outcomes over here? The count is 4. What is the formula for probability? Probability is equal to number of outcomes favorable to the event. That means the outcomes which satisfies the event asked in the question divided by total number of outcomes. For the first part of the question, exactly 2 heads. So we are only interested in this outcome. This outcome is our favorable outcome. There's only one favorable outcome. Out of a total of how many outcomes? Out of a total of 4 outcomes. So the first answer would be 1 by 4. Second answer, at most 2 tails. You need to check which all of the outcomes given satisfies at most 2 tails. What do you mean by at most 2 tails? Maximum 2 tails. You cannot have more than 2 tails coming. Is there any outcome over here where there is more than 2 tails? No, there is no outcome where there is more than 2 tails. If you look at this one, this has 2 tails. This has 1 tail, this has 1 tail, this has 0 tails. Everything over here is less than or equal to 2. Remember, the meaning of at most 2 tails means that the number of tails must be less than or equal to 2. That is the meaning of this. Maximum 2. Even 0 is included in this. This is a common mistake, not including 0. 0 is less than or equal to 2. So 0 is included in at most 2 tails, which means that all the 4 outcomes here are favorable outcomes for this event. So the probability would be 4 by 4, which is 1. 1 is your answer over here, and that's the maximum probability possible. Let's look at 16th question. 2 root 2 plus 1 the whole square. Even when you have irrational number combinations like this, you're going to use the same identities which you have learned. Which identity would you use here? You will use a plus b the whole square is a square plus 2ab plus b square. Do not forget 2ab. A plus b whole square is not just a square plus b square. There is a 2ab over there. Let's use this. You get 2 root 2 square Is it okay to write it like this? My recommendation is no, don't write like this. When you have 2 root 2 square, please put bracket so that you remember you have to square both of them. You have to square 2 and also root 2 when you're squaring 2 root 2. Then you have plus 2 into 2 root 2 into 1 plus 1 square. This would give us 2 root 2 the whole square is 4 into 2. I'm squaring 2 and I'm also squaring root 2. Remember, root 2 into root 2 is just 2. And then we have 2 into root 2, which is 4 root 2 plus 1. This becomes 8 plus 4 root 2 plus 1, which is same as 9 plus 4 root 2. That's the answer for 16. Let's look at 17th question. 17th question says, find 5 rational numbers between 1 by 5 and 1 by 7. How do you find rational numbers between any two given numbers? The important first step is to make sure the denominator is the same. Remember, you can actually have infinite number of rational numbers between any two given numbers. They are just asking you to find 5. If you make 1 by 5 and 1 by 7 having the same denominator, I need to ensure that the denominator is an LCM or a multiple of the LCM. Let's make it the LCM. That's easier here. I can multiply 5 with 7, numerator also with 7, 7 with 5, numerator also with 5, to get the corresponding equivalent fractions which have the same denominator. So we know 1 by 5 is 7 by 35, right? And 1 by 7 is 5 by 35. Now there is a problem. The problem is I cannot find 5 rational numbers very easily between 7 by 35 and 5 by 35. Because very easily what comes into your mind, between 5 and 7 you have 6 by 35. So 5 by 35, 6 by 35, 7 by 35. That's it, done. We need 5 rational numbers in between. The goal then would be to convert this to other equivalent fraction, but having bigger gap in between the numerators. How can we ensure a bigger gap between the numerators? Multiply with a bigger number, so the denominators still remain the same, but the numerator becomes bigger with a wider gap. I will multiply both with 10. Okay? This becomes 70 by 350 and this number becomes 50 by 350. You can see there is a sufficient gap over here between 50 and 70. We can write more than 5 rational numbers. We can even give more than 10 rational numbers in between 50 and 70. So once you obtain the equivalent rational number form of these numbers, then you can list down these 5 rational numbers. So you can say that 5 rational numbers are any numbers you can select. I will select maybe 51 by 350, 52 by 350, 53. Then we have 54 by 350 and 55 by 350. Your teachers in school might be okay with you leaving your answer in this way, or they might require that you reduce it into simplest form. Depending on the expectation in school, ensure you present your final answer. You can leave it like this if it's allowed. If you're expected to cancel out common factors and reduce it into simplest form, do that. Okay. 18th answer. 18th has 2 parts. Let's answer both. So for the first one, it's just identifying the quadrant. Do you recall what we discussed about quadrants in the previous video? If this is the x-axis, this is the y-axis. Remember, this is the positive x-axis and here you have the negative x-axis. This is positive y-axis, that's the negative y-axis. Now, quadrant's sign depends on what are the signs of the axis it is bound by. This is the first quadrant bound by positive x coordinate, positive y. This is the second quadrant bound by negative x and positive y. Third quadrant, negative x, negative y. Fourth, positive x, negative y. Let's look at the coordinates one by one. If you look at option A, both are negative. -9, -3. Both negative means third quadrant. Option B, 2, 9, both positive, first one. -3, 4, that means negative x, positive y, that's the second quadrant. And option D would be 4 minus 3, which is the fourth quadrant. Easy 2 marks, but you should be careful. Often careless mistakes happen here. With just being a little careful, you can easily secure marks in this chapter, coordinate geometry chapter actually. Let's look at the OR question. So if 2, 3b is equal to minus a, 3, what are the values of a and b? You are having two coordinates which are equal to each other. Remember, if a coordinate x, y is equal to a coordinate a, b, that means x is equal to a and y is equal to b. X should be equal to a and y should be equal to b. That's when you have two coordinates which are equal. So in this particular case, you can say that 2 is equal to minus a. This would mean that a's value is minus 2. We found a. So we are just equating both the x coordinates which is given over here. You can equate both the y coordinates. You get 3b is equal to 3, which means that b is equal to 3 divided by 3, which is 1. That was also other easy 2 marks. Remember, you just have to equate corresponding x coordinates and corresponding y coordinates. The x coordinate of the first one to the x coordinate of second. Y coordinate of first one to the y coordinate of second. So I think that was the end of the section B, the 2 mark questions. We'll start off with section C, 3 mark questions. Section C questions, I can see have few questions which are based on important concepts. Yeah, let's look at this. 19th question. 19th question is a question based on the concept of converting a non-terminating but repeating decimal number into P by Q form. That means into the P by Q form of the rational number. Remember, rational numbers could be terminating or non-terminating but repeating. But rational number definition says that we can write any rational number in the form of P by Q, where P and Q are integers, Q not equal to 0. So when they ask you to convert this into P by Q form, this P and Q have to be integers. And how do we do this? First step, the very first step is say that let x equal to whatever is the repeating decimal that they have given. So 1.2727 ... Remember, this 27 keeps repeating. Okay. So x equals 1.27272727. Even if the question was given as express 1.27 bar in P by Q form, it means the same. It means that 2727 keeps repeating. Your next goal, once you write this step, the next goal is to make sure you get another number. I want one more number which will have 2727 repeating at the end of it. Okay, that's the goal. How will I get this? Another number with 272727 repeating. What I'll do is, I know here 2 digits are repeating, right? So if I multiply by 100, if I multiply this number by 100, this decimal point will move 2 places to the right. And after that, this 272727 only will repeat. So I'm getting another number with the same repeating part. All I'm doing is multiplying both sides by 100. So we get 127.272727 keeps repeating. What was the advantage of getting the same repeating part after the decimal point? Now what happens is, if I subtract both these statements, if I do 2 minus 1, I'll get 100x minus x. Subtract the LHS. 100x minus x will be 99x. When you subtract RHS, what do you get? This 0.27 which is repeating, that gets cancelled off. You have 127 minus 1, which is 126. Do you see what happened? That complete repeating decimal part just went off because we had made it the same. Now it's very easy. I can just divide both sides by 99. So you take 99 here. You get x equals 126 by 99. Cancel any common factors. We know both are divisible by 3. How do you make out? The sum of digits over here is in 3 tables, 6 plus 2 plus 1. 99 also sum of digits is in 3 table. Oh, actually both are divisible by 9. 6 plus 2 plus 1 is 9, right? So both are 9 table. I can divide by 9 directly. What do we get? I would get, this is 14, 9 times 14. Yeah. And this is 9 times 11. So x is equal to 14 by 11 would be the answer for this question. What was x? X is nothing but the question itself. So we just expressed that number 1.2727 dot dot dot. We expressed as p by q form 14 by 11. Let's look at the 20th question. Represent root 3 on the number line. Use proper geometrical tools and make the diagram unit at least 4 centimeters. Okay. So if I want to get root 3 on the number line, okay, how do I actually draw? We can't measure root 3 or using a scale. Like a number line means that I am having a straight line over here. Okay, this is a straight line. I would have -1, then I will have 0, then I have 1, then I have 2. Correct? This is a number line. And when you are drawing the number line, there is a special instruction in this question. Make the unit at least 4 centimeters. So when you're drawing this on your paper, make sure they're uniformly distanced and make sure that each distance over here is minimum 4 centimeters. You don't have to write this, no need to write 4 centimeters, but you need to ensure that this distance over here is 4 centimeters at least. Okay, so each unit must be equidistant and make sure it is minimum 4. Or take exactly 4, that's okay. Then I need to mark root 3 on this number line. Now, where exactly would be the position of root 3? One way you could think of doing it is marking the, finding the value, approximate value, because we know that root 3 would be an irrational number, non-terminating, non-repeating, which means getting exact position is tough. So you might be thinking, let me approximately mark it. But of course, that's not going to be permitted. You want to mark exact value of root 3 on this. Now, how do we get exact value of root 3? For this, we use the Pythagoras theorem. We are going to use Pythagoras theorem for this. How do you use Pythagoras theorem for this? If I look at root 3, okay, root 3 is the same as root of 1 plus 2, right? Root 3 is same as root of 1 plus 2, which is same as square root of 1 square plus root 2 the whole square. Root of 1 square plus root 2 the whole square would be root 3. So again, I'm repeating, square root of 3 is same as square root of 1 square plus root 2 the whole square. What does this mean? This means that 3 is equal to 1 square, okay, or let me just write it in a different way. Yeah, this means that root 3 square, okay, is equal to 1 square plus root 2 square. What theorem does this look similar to? This looks similar to the Pythagoras theorem, right? This is looking very similar to the Pythagoras theorem, where you're having a triangle with sides root 2, 1, and the hypotenuse is root 3. So this would be a right angle triangle with sides root 2, 1, and root 3, since this is satisfying the Pythagoras theorem. So what I understand over here is, if I can get root 2 somehow, if I get the value of root 2 somehow, then drawing root 3 is also simple. Because root 3 would be the hypotenuse of this right angle triangle. Okay. Now, how do we go about getting root 2? For root 2, what we will do is, we know root 2 is the same as root of 1 plus 1, which is same as root of 1 square plus 1 square. So we can say root 2 square is same as 1 square plus 1 square. The square of root 2 same as 1 square plus 1 square. This tells you if you had a right angle triangle where this side was 1, this side is also 1, then what will happen to this hypotenuse? What will be the hypotenuse measurement? The hypotenuse measurement will be root 2. So we can obtain root 2 by taking a triangle, a right angle triangle with 1 and 1 as the sides. Then we can get root 2 over there. Once we get root 2 measurement, then we know how to get root 3. So yes, this is going to take some time to solve. You need to have all your geometrical tools in place. You need to have scale, pencil, and your compass in hand. If you don't have a compass and you have a protractor, that's also okay. Now, let's see step by step what we would do. First thing, take your scale, okay? You draw a long line. Then please ensure that you mention how much is 1 unit equal to. I'm taking 1 unit exactly as 4 centimeters. So when you use your scale and measure, please take 4 centimeters exact, 1 unit. Then you will have mark minus 1, 1, minus 1, 0, 1, 2, all at a distance of 4 centimeters from each other. Then what do? Now, in order to measure this particular measurement, that means in order to get root 2, I will need a triangle like this. I have 1 over here and I will need 1 here. So from the origin, imagine that this point is 0, 0 over here. From 0, if you measure 1 here and if you measure 1 here and join this, I know that would be root 2 measurement. So what you do is, we know over here that this is a measurement of 1. Okay, all constructions which go lightly, I'm marking in red color for you to see here. So I'll mark this as 1. Then what do? Use your protractor and measure 90 degrees over here and draw a line here. Okay, using your protractor, you will measure 90 degrees here. Once you draw this line, I need to mark how much? 1 unit over here. How do I measure 1 unit? To measure 1 unit, you need to take 4 centimeters. To measure 1 unit, take 4 centimeters length over here because we have taken 1 unit equals 4. So you measure 4 centimeters and you know that this is also 1. Then what do? Now we know if I join this point and this point, the hypotenuse if I mark here, we know that this measurement will be how much? This measurement will be root 2. Correct? That measurement is root 2. Okay. Then what do? We could bring root 2 down to the number line over here. We can bring root 2 down to the number line here. So if you use your compass, put the needle over here. The compass needle will come here. The pencil point of the compass. You have two sides, right? With the needle and the pencil. Put the pencil point over here. You measure this length using your compass and bring that down. Draw an arc so that you get the same measurement here. This measurement becomes how much? It becomes root 2, right? So you got root 2 over here. You are measuring, I'm repeating this again. You are having root 2 measurement over here because this is the hypotenuse of this triangle having sides 1 and 1. Once you measure that, keep your compass point here. That means compass needle point here and rotate the compass so that this root 2 value comes down here. Now I know that this distance is root 2. How do I get a measurement of 3? We need a right angle triangle where root 2 is the base and 1 is the height. Then I know when I use Pythagoras theorem, this will be root 3. So what do? Again use your protractor. Again mark 90 degrees over here. At this root 2 place, mark 90 degrees. So we already know this base is root 2. You got this. You need a height of 1, right? Again measure 4 centimeters over here for a height of 1. So you measure 4 centimeters, you reach this point. We know this is 1. Join this. Now, this line over here, when you join, this measurement will be root 3. That is your root 3 measurement. Whatever is the measurement of this line, that will be root 3. Next, what do? Using again the same principle of rotating the compass. Fix your needle here. The pencil point of the compass comes here. rotate by fixing the needle here. This will come down this way. Okay. And wherever it intersects the number line, this value is going to be root 3. So you can circle that. Root 3 is the value which you have measured here. This distance over here is what's going to be root 3. This is how you would mark root 3 on the number line. Please ensure you are practicing this. Okay, just watching it won't help. You need to actually draw and practice doing the construction so that you get the necessary speed in the exam. That was about 20th question. In fact, in 20th question, we learned how to mark both root 2 and root 3 on the number line. Let's go to the next one. 21st question. So if you see the 21st question, ABC is an equilateral triangle. Find the coordinates of its vertices. It's an equilateral triangle. Equilateral triangle means all sides are equal, correct? Okay, let's understand how this triangle is going to be. Okay, first of all, this is the origin. From the origin, if I move 6 units towards the right, I'm moving 6 units towards the right, what will be the coordinate of this point? The coordinate of this point would be 6, 0. Y coordinate is not changing. We have not moved up or down. We are just moving right 6 from here. Oh, I think I made a mistake. This alone was not 6. My bad. This entire measurement was 6, which means this measurement was only 3. It's only half of 6, which is 3. So we are moving 3 units to the right, okay? So that's the correction I need to make. This is 3. And when I move to the left from the origin, I'm moving 3 units to the left. So 3 units to the left means the x coordinate is changing to minus 3. Y coordinate remains the same. Y coordinate is still 0 only. Okay? All right. Next, what we need to do, we need to somehow find the coordinate of A. How do I find the coordinate of A over here? This was the origin. This was 0, 0. We know that A's coordinate would be what? A's coordinate will be 0, some y coordinate over here. I don't know exactly what the y coordinate is, but we know that the x coordinate will be 0 because for reaching this point A, I didn't have to move right or left. I just had to move up. So the x coordinate is 0 and the y coordinate is y. How do we find this y coordinate? See, this is an equilateral triangle. An equilateral triangle means all side measurements are equal. What is the measurement of this side? The measurement of this side is 6, right? So if that is the case, we know that the measurement of, let's say, AC must also be 6. If BC is 6, it's an equilateral triangle, so AC must also be 6. How do we find the distance AC? We use the distance formula. You can find this distance AC by using the distance formula. What does the distance formula say? The distance formula says that root of x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to the distance between the 2 points. This length of side will be the distance between the 2 points, 6. So 6 over here is the distance between C and A. Now let's substitute these coordinates. I will get root of 3 minus 0, x2 minus x1 the whole square plus y2 minus y1 the whole square, 0 minus y the whole square. That will be equal to 6. We will then get, okay, at the same step, no, I'm going to square both sides also. So we are going to get 3 square plus minus y the whole square will be same like y square. To remove this square root symbol, what I will do? I will square on both sides to remove this root symbol. So we will get 6 square here. This way I get y square is equal to 6 square minus 3 square, 36 minus 9, which would be 27. Yeah, Y square is equal to 36 minus 9, which is 27. Which means y is equal to square root of 27. How can we simplify square root of 27? 27 can be written as 9 times 3. So I can write this as square root of 9 multiplied by square root of 3, which is 3 root 3. Okay, so we found y value also. How do you conclude your answer? You'll say, therefore, the vertices are A is 0, comma 3 root 3. B was minus 3, 0. And we have C as 3, comma 0. This is the way you can answer this particular question where you need to find missing vertices. Use the figure itself to help you first. Use the figure to help you in terms of getting some of the coordinates. And then whatever missing coordinate is there, you might have to use midpoint formula or you might have to use distance formula depending on the question. Here we use distance formula and we got the answer. Okay. There's an OR question to this also. Check whether the points M, A and G are collinear or not by the distance formula. We need to use distance formula to test what type of points M, A and G are. Now, if to answer this question, what do you mean by collinear points? Collinear points are points which lies on the same line. See, you know that a line is formed out of infinitely many points. All these points are collinear to each other, meaning they are on the same line. If I mark 3 points over here like A, B and C, for example, if I mark A, B, C, how do I know whether these are collinear or not? We know from here in the figure, AC is the biggest measurement of the length over here between A and C. If these three are on the same line, then the measurement of AC must be equal to AB plus BC. This is the logic that we use. This measurement must be the same as the sum of the smaller two measurements. AC must be equal to AB plus BC for the 3 points to be collinear. Now, in this question, I have points M, A and G, but I don't want to draw it. I don't want to first, check what is this position of everything with respect to each other. What I will do is, I'll just calculate all the 3 distances, MA, AG, MG. We'll just calculate all the 3 distances possible. So I will calculate what is MA, we will calculate what is AG, and we will also calculate what is MG. So we're going to use the same distance formula which we just learned earlier. What will MA be? MA will be root of minus 3 minus 0 the whole square plus minus 2 minus 0 the whole square, which will be root of 9 plus 4. This I am getting as root 13. So I just use distance formula over here to get this answer for measurement of MA. Let's look at measurement of AG. AG measurement will be 4 minus 0 the whole square plus 2 minus 0 the whole square. So this is the difference between x coordinates and this is the difference between y coordinates. We are doing x2 minus x1 square plus y2 minus y1 square. By the way, if you do x1 minus x2 also, it is okay. y1 minus y2 also, it's okay. There's no problem because anyway you're squaring the value. Important thing is you're subtracting only x coordinates and then you're subtracting only y coordinates. That's the important part. So here I get root of 4 square plus 2 square, which is root of 16 plus 4, which is root 20. Right? Root of 4 square plus 2 square, 16, 4, yes. Root 20. What's the measurement of mg? Mg measurement would be root of 4 minus minus 3 the whole square plus 2 minus minus 2 the whole square. Again, I'm taking the difference between x coordinates, difference between y coordinates. So 4 minus minus 3, that becomes 7 square. 2 minus minus 2, what is 2 minus minus 2? 4, 4 square. This I'm getting as root of 49 plus 16, right? Which is root of 65. Okay. What did I tell you earlier? In case these points are collinear, then what would happen? The sum of the two smallest distances that you get here, which are the two smallest distances, obviously root 13 and root 20 are smaller than root 65. If they were collinear, the value of root 13 plus root 20 must have been equal to root 65. These are irrational numbers which are not related. We can't even add root 13 plus root 20. So definitely root 13 plus root 20 is not equal to root 65. Root 13 plus root 20 will be a totally different irrational number, right? You will say over here MA plus AG, which is equal to root 13 plus root 20, and you can say mg is equal to root 65. Since MA plus AG, that means the sum of the two smaller distances, is not equal to bigger distance, the points are not collinear. That's how you answer. If they were collinear, what would have happened? If they were collinear, the sum of those two smallest distances would have become equal to the biggest one. But here it's 100% not equal to the biggest one. Okay, so you don't have to do anything else. You just have to say that it is not equal. Hence, the points are not collinear. Let's look at 22nd question. Oh, these are very important, these type of questions. You have to use identities on irrational numbers. So if you look at part A, root 7 plus root 5 into root 7 minus root 5. What do we do here? This is just A plus B into A minus B. How do you calculate A plus B into A minus B? A plus B multiplied by A minus B is A square minus B square, right? You're using this identity. In fact, root 7 minus root 5 is called the conjugate. Root 7 minus root 5 is called conjugate of root 7 plus root 5. Alright? Okay, let's apply this identity. You get root 7 square minus root 5 square. What is root 7 square? 7. Root 5 square, 5. 7 minus 5, 2 is the answer here. Let's look at part B. B is 2 minus root 5 the whole square. Let's use A minus B the whole square identity. What's A minus B the whole square? A square minus 2AB plus B square. Use the same over here. 2 square minus 2 into 2 into root 5 plus root 5 square. We get 4 minus 4 root 5 plus 5, which is 9 minus 4 root 5. That's it. That's the answer for this part A question. If you are attempting the OR question, let's see what we would get. So for the OR part, root 8 plus root 50, root 72 plus root 98. There are two ways to do this. One is you completely prime factorize and then take the square root. Another way is you try writing these numbers which is inside the square root symbol in terms of a perfect square number. What are perfect squares? 1, 4, 9, 16, 25, 36, 49. Okay, and then you have 64. So these are the perfect square numbers. You can write these numbers as multiples of any of these. I can see here root 8 is root 4 into 2. 50 is root of 25 into 2 here. I can see 72 is 36 times 2. 36 times 2 is 72. And what about 98? 98 is 49 times 2. If you did not know this, you would have ended up prime factorizing and finding the complete factorized form of all these numbers. This would be answered as root 4 multiplied by root 2. Here you can do separately root 25 multiplied by root 2. This is root 36 root 2, root 49 root 2. Remember, one very important point to remember is, if you are having root of a plus b, it's not equal to root a plus root b. You cannot separate root of sum of two numbers as root of first one plus root of second one. That's absolutely wrong. But if you're having product, it's okay. You can write this as root a multiplied by root b. What's the answer here? 2 root 2 plus 5 root 2, 6 root 2, and then 7 root 2. This answer would then become, everything is having root 2. They're all like light numbers, right? All are having the same irrational part. So you can just add them up. 5 plus 2, 7. 7 plus 6, 13. 13 plus 7, 20. We get the answer as 20 root 2. You can leave your answer this way, no problem. Let's look at the last question from this section, 23rd one. If you roll a standard 6-sided die, what is the theoretical probability of getting a 4, getting a prime number greater than 4? Most common mistake made while answering the first one is telling 4 by 6. That's wrong, okay? The probability of getting 4 is not 4 by 6. When you roll a die, what are the outcomes possible? 1, 2, 3, 4, 5, 6. These are the outcomes possible when you roll a die. In this, which outcome or outcomes is favorable to the first option? The first question is telling probability of getting a 4. There is only one outcome which is favorable for the first one. So the answer will be 1 divided by 6 because there's only one time that 4 can appear. Answer would be 1 by 6 over here. Okay. For the second part, getting a prime number. What's the probability of getting prime number? Which all are prime here? You can make a list of the favorable outcomes. The favorable outcomes are 2, 3 and 5. These are the prime numbers. How many favorable outcomes are there? You have 3 favorable outcomes. 3 out of how many? 3 out of 6. So 3 by 6. 3 by 6 probability is 1 by 2. This is the answer for this second part. What about the third part? Getting a number greater than 4. Greater than 4 do not include 4 when you're checking greater than 4. The favorable outcomes in this case would be 5 and 6. How many favorable outcomes do you have? 2. 2 out of 6 satisfies a condition which is given in the third part. So we get 2 by 6 as the answer, which is 1 by 3. This is the answer for this 23rd question. So that's it for this video. I have solved section B and C in this video. We will solve section D in the next video. All right, see you. Bye-bye.